squared plus 1 minus 1 is less than E. Our absolute value of n squared over n squared plus 1 minus 1 is less than E. Basically just solving for E, or for n. They give you the value of epsilon, which is 0.0004. I change n to n squared plus 1 over n squared plus 1, which is still 1, so I can combine it. N squared minus n squared plus 1 over n squared plus 1 is less than E, or epsilon. Do some math. Negative 1 over n squared plus 1, absolute value, is less than epsilon. I plug in my epsilon. I multiply both sides by n squared plus 1, and then divide both sides by my former epsilon 0.0004, which gives me the absolute value of negative 1 over 0.0004 is less than n squared plus 1. Absolute value of negative 2,500 is 2,500 minus 1 gives me 2,499 is less than n squared. Take square root of both sides. I wind up with 49.9899 is less than n. Any questions?
What is, I just have a question about what is on 1, 2, 3 on the third row, the last one, what does that say? All the way to the back. Go over some more, the last part. Yeah, right there, what does that say?
Negative 1 over 0.0004 is less than 0.0004 times 3n plus 1 divided by 0.0004.
Is there a negative missing? Here. Yeah. Right here. I don't think it matters because you got to have some value in there, right? So you can throw the negative away. Any other question, Kyron? You look worried.
Yeah. You see, okay, the second row it says n squared minus n squared plus 1 at the top. And then you ended up getting negative 1 over n squared plus 1.
Right.
How did you end up with negative 1 there?
Because the term was n squared plus 1, and you're subtracting this term from this term, so you're going to wind up with a negative 1.
Right, Kyron, when he does the common denominator, that negative applies to everything up top. He wasn't missing those parentheses, right? You see how the line above it, it's n squared minus that n squared plus 1, all in the numerator of that second term. Okay.
I think I had them yesterday.
And now second thing, where did you get 3n plus 1 on the third row where you just explained to Scorpio this time? You said 0.0004 times 3n plus 1.
Oh, sorry, I got my problems confused.
Okay, now it makes sense.
There you go.
Scorpio?
On the fourth row, and we'll say 2,500 minus 1, where that minus 1 comes from.
This side right here, I showed step by step. N squared plus 1 minus 1. I'm subtracting 1 from both sides to keep the...
So you were trying to get it by itself, right? You had n squared plus 1 on the other side.
It kind of confusing because
I understand. You got it now, right? All right, we good on that one? So let me point out what's important about that one. I mean, other than the fact that he demonstrated his algebraic prowess, right? What that says is, what is the sequence here? What are the terms of the sequence? What sequence are we talking about? N squared over n squared plus 1, right? What do we think it converges to? 1, right? This is the limit of your sequence. This is the sequence, right? So if we go over here, what he just showed was you take 1. You take a distance. That's your distance, is the way you should think of that little epsilon as a distance. 1 plus epsilon, which is 1 plus point, how many fours? 0, 0, 0, 4. And over here, 1 minus epsilon, which is 1 minus 0.0004. What he showed was that if n is bigger than this, so I would say my capital N is 50, that's the first term of this sequence that's inside that interval. What's the first term of this sequence? It's 1/2, right? So somewhere over here is 1/2. The next term of that sequence is 4/5. Somebody did their homework. The next one is 6/7. Dot, 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 right? A50 is the first one that's inside that interval. Clear? Now what's the point? The point is, when we say a sequence converges, it means no matter what epsilon is, there is some number so that it does, no matter how small I pick this interval, no matter how small I pick it, eventually there's an n that gets you inside here. We did a specific example first. That's what this problem was. Now, jumping ahead to what Jordan did here, I'll let him explain it, but what's the only difference between what Mark did and what Jordan did? Here, there's a specific choice, right? There's a specific choice for epsilon. I picked one just to set you up to do the algebra, because the algebra is hard enough, even when you're working with numbers. And he figured out that for this epsilon, this is the natural number n that gets me inside this interval. What Jordan's going to go over, I'm going to have him go over it next and skip over 260 and 261 first. He's going to show, notice that his n depends on epsilon, right? What should I get out if I put 0.004 in for epsilon?
0.004?
If I put for epsilon right here, if I put 0.0004, what should I get out?
Same thing that Mark did, right?
Right? So somebody do that. If n is greater than square root of 1 minus 0.0004 over 0.0004, tell me what you get for that number. We'll check them both at the same time, right?
Yeah.
Wow, 49.98999.
So as epsilon gets bigger, a sub n gets smaller.
Right, so if I pick a smaller epsilon, if I pick epsilon equal to 1 over 10,000 and plug it in there, I'm shrinking my interval, right? So it's going to take longer, a larger value of n before I get inside there. The sequence converges if no matter how small I pick the interval, eventually the sequence gets in there and stays in there forevermore. Okay, Jordan, show us what, the work you did. Now we've checked it, you can do it with confidence, right? we know it works because we did it for one number. If it's true for one number and we're engineers, it's true for everything.
Alright, so I started off by writing this down. I actually just got that from 258, but with the absolute value sign, once you move from 1 over, you eventually get 1 minus, you get n squared over n squared plus 1 is greater than 1 minus e, and it's less than 1 plus e. So I just separated it out. First I multiplied both sides by n squared plus 1. We got n squared on one side. After following, I get an n squared, so this cancels out and makes 0. We got 1 over. I got negative 1 equals n squared plus e, subtracting e, divided by e, and then square rooted to get a value for n. And I did the same thing over here, and I just got n is greater than the square root of negative 1 minus e over e, and is greater than the square root of 1 minus e over e. Again, this is the negative 1 and the positive 1. No questions?
Okay, so I would point out one observation. We're all engineers, so we're used to blowing things up, right? Work at these chemical plants, that's what they do all the time. I don't know why they pay y'all so much to blow things up all the time, but they do. Jordan just blew up a chemical plant, right?
Yeah, because it's supposed to, the signs switch, don't they?
Well,
You can't take. Did you want to put an absolute value on it?
Yeah.
he took the square root of negative 1's negative, epsilon was positive, so the top's negative, and the bottom's positive, so the inside's negative, right? You're not in trouble because the last line says, is n squared bigger than this negative number? Well, yeah, if n is 1, 2, 3, 4, 5, then it's always bigger than a negative number, right? So once you get to this line, you're actually done. And this line just says, wow, any n works on this side. Well, why is that? Look at the two sides of the equation. This sequence is increasing up to 1, right, Jordan? Now, which values of n will it be less than 1 plus 1 epsilon? Well, it's always less than 1. So it's definitely always less than this
I was
side.
wondering what the significance was in 0 less than e is less than 1.
Right.
I get it now.
So, well, yeah, the epsilon needs to be positive because I definitely want to build an interval around 1 plus epsilon, 1 minus epsilon. But when you look at this equation and you split it up into the two sides, if the sequence is increasing, you kind of get this side for free, right? This sequence, n squared over n squared plus 1 is less than 1 is always true. Because if you multiply it across, you'd have n squared less than n squared plus 1, 0 less than 1. So it's always, this sequence is 1 is an upper bound for the sequence. So you don't actually have to do all the work on this side. Well, you either have to do this and say, hey, the sequence is always less than 1, so the sequence is always less than 1 plus epsilon, right? If it's always less than 1, it's less than 1 plus some small number.
Right.
So you get one side for free. Now, how do you do this? There's nothing wrong with doing both sides. Just, again, like Mark, showing off your algebraic prowess is never a mistake. But one side ends up just saying, well, true for all n equals 1, 2. It's always true. So this side just doesn't tell you anything of interest. But this side tells you what you needed to know, that if I shrink epsilon, there is an n such that the terms of the sequence end up inside the open interval.
Got a question.
Mhm.
I thought when you throw a negative on the other side of an inequality, it switches the sign.
It depends on what you mean by throw. Multiply or add.
So I guess adding or subtracting wouldn't change it.
Right. If A is less than B, then A plus C is less than B plus C. You add anything to both sides, that's fine.
So it's just
You
multiplication.
multiply or divide by a negative number or take reciprocals, right? 2 is less than 3, but 1/2 is not less than
Right.
1/3.
Yeah.
You take reciprocals or you multiply or by a negative number or you divide by a negative number.
Okay.
Yep, that's why you take calculus, learn your algebra and your trig.
Lot.
Okay, 260 would be next, Nick?
We've actually seen this problem before at 258. Scorpio did it. And the majority of the problem is actually algebra. The difference between what Scorpio did and what this is the one on 258 actually had a set number for epsilon. So you're trying to figure out how big of a number you have to get below, to go below a certain decimal point of epsilon. And so the difference between this one and that one is you're actually just solving for what does n have to be to get below 1. So it's just the same problem, just a difference in the number system. The only thing that I had a struggle with on this one is we're actually trying to figure out what capital N has to be in order for subletter n to be greater than or equal to capital N. And that's where I got a little confused, and maybe somebody else knows a little something about it. But the problem wanted you to find where lowercase n was greater than or equal to n. Now, if I just plugged in lowercase n at 4/9 into the original problem, I'll come back with equals to 1. But we're trying to figure out where it's less than 1. So n capital would have to be somewhere 4/9 plus a really small number. Or we can just say capital N equals 0.44444, and at some point round it up a little.
Okay, so two things, Nick. One, on this problem is like Jordan's problem in the sense that what we want to do is get it less than epsilon. We want to I give you any small number, positive number, epsilon. You find the n that works. Now you just did exactly what you have to do if that epsilon is 1.
Right.
But now I want you to go back and do the algebra for replacing that 1 with epsilon and work all the way through, just like he did. So you get a formula for n in terms of epsilon.
You mean plug in 4/9 in as epsilon?
No, like, I mean, instead of using the 1, you would just leave it as epsilon and from there and get n by itself.
Or put .99 as epsilon.
Oh, I got you.
So just like he did over here, the goal, when Mark did it, and this is, I know this is hard, but I'm trying to stair step everybody along the way. For Mark, I told him what epsilon to use, right?
Right. No, that's what I got confused. 'Cause in the previous problems, you give us what to go for.
Correct.
And
And this one I
like,
didn't, because what I want you to do is put the epsilon there,
Right.
and then do all the algebra, and then this will be in terms of epsilon, just like what he got over here was in terms of epsilon.
Right.
So just redo it this evening, bring it up for Friday, and just do the exact same thing, except your n will be in a formula in terms of epsilon. You can check whether your formula is right by going back and looking at Scorpio's, because he did it for some number, right? Just like over here, I checked. Mark did it for this epsilon. And for this epsilon, he got this in.
Right.
And then I checked with this formula over here when, as soon as I saw Jordan had a complicated formula, I thought, well, I could check all his algebra, or we already did it with this epsilon, I'll just put this epsilon in and see if we get the same number, capital N out. We don't guarantee that his algebra is right, but it leads me to believe it's right. Make sense? So go back, I'll do it with the epsilon, and we'll put it up on Friday. You can come in first thing before, you don't even have to wait. Just throw it on the board. 260, well, 261 I guess is now. But you can go ahead, Tyler, you're already up there. Go ahead. Finish the front board, and then we'll all turn around one time.
Problem said, consider the sequence xn equals 1 over n for all, n equals 1, 2, 3, and it says sketch and define a function so that f f agrees with x of n at all natural numbers, but the limit cannot equal 0. So I've got my ace of 1, 2, 3, 4, and 5 off of 1 over n, and then I see what I had, and I went back and did the limit, and I seen if you subtract 1, because this right here is approaching 0, and the limit can't approach 0, so if you subtract 1, it's approaching -1 instead of 0. And I mean, it could have been 1 over n, and then it would have just been 0, -half, -2/3. And you can see it's approaching -1. Then I did the graph for the limit at -1.
Okay, Tyler, I'm confused. Do you have a do you have a formula for your graph, or do you know f of x?
No,
No, okay.
no.
Well, show me where 1 is on your graph, just 1 on the x-axis. Where is 1?
Right here.
Okay? And so mark that point, that's 1 comma 0.
Mhm.
Now, for our sequence, a sub 1 is 1, right? Our
Mhm.
first term of our sequence is 1.
I graphed the new function that I did instead of the old one. I mean, it would have been like this. Let's get it up.
So, but the question asks for a function. I'm just trying to figure out. The question asks for a function that agrees with the sequence at every natural number, right?
Yes, sir.
So f of, write this up there. F of 1 should equal 1. F of 2 should equal 1/2, and f of 3 should equal 1/3. Dot dot dot. And it doesn't look to me like your function satisfies that. You with me?
Am I wrong? What does it mean by whenever it says agrees with that at all natural numbers?
So maybe my language wasn't precise enough. What I meant was what I wrote up, what I just had you write. I meant that the function, the y value of the function at 1 equals the first term of the sequence at 1. The y value at 2 of the function agrees with the second term of the sequence. The y value at 3 agrees with the third term.
I thought that you wanted a new function to where it wouldn't approach or converge to 0.
I do want it not to converge to 0, but I also want it to agree with the function. So, for example, I'm trying to show the difference between functions and sequences, and I may not be succeeding, but I'm trying. So we're both in the same boat. You tried to do something to quite succeed. Well, so did I. What I'm trying to do is point out the following. So our sequence is only defined for natural numbers. So at 1, it's equal to 1, right? If I was to graph my sequence, it would look like this. Because its domain, the domain of our sequence, our definition of a sequence, is a function with domain the natural numbers. So if I graph a sequence, all I get is a bunch of points. So I want to say, can you come up with a function that goes through those points, agrees with that, but does not go to 0 as we go out to infinity? So now you got something to think about for Friday, which is just a good way to keep you off the streets. So you understand my question now? Is the question more clear? I want the function, so I want f of 1 to be the same as 1 over 1, f of 2 to be 1 over 2, f of 3 to equal 1 over 3, but I want the limit as x goes to infinity of f of x to not be 0, even though the limit as n goes to infinity of 1 over n is 0, right? These points are heading for 0, aren't they?
Mm-hmm.
But I want to construct a function where the function agrees with these points, but the function doesn't go to 0, which seems kind of counterintuitive, right? You're like, well, how could that happen?
Does it increase them?
Well, I won't say anything more. It's something for everybody to think about for Friday. Okay, we got one vote that it's impossible. Maybe I should have said construct one or prove that it can't be done. But it can be done. It can be done. I'm not trying to trick you. Okay, Gerardo, show us 261. You draw me a picture and tell me. Gerardo?
I'm stopping. If n is odd, even, X of n equals 1. So I went ahead and just, it should have been a 1, and just wrote out sums. So then, I guess, I just knew that, you know, with